tell you some things to add to it, because the way that sheet's going to work is like the things I have listed out at the top are just reasons or statements that kind of go together majority of the time. So the way you get good at proofs is you kind of look at diagrams and you base what you're going to write off, like what you're going to write in the proof based on the diagram. So the way I have this is, like the first one, for example, says you start with a linear pair. These are like the common things you would say after that. And the way I have this set up is, what I'm saying is, if you see this thing given to you, meaning if you had a picture like the one that's up there, so like this part would come from the diagram. Regardless of what you're trying to prove, for where I'm at right now in the course, if I saw a picture like this and I was writing some kind of proof, like the things I would point out is I would go, those two make a linear pair, so do those, and those are vertical angles. And everything that I just mentioned there has a specific property to them. And you want to get in the habit of listing out all the properties. And when you list them out, right, so we're writing a proof, that's the main idea. When you list them out, everything that you know as a property will end up coming on this side. Like, if I looked at this and I saw that 1 and 3 were vertical angles were congruent. So I would say like 1's congruent to 3. Even if I don't know where to end up, the point of having these statements is so I can list everything that I see in the picture or what's given to me. So what I'm giving you here is like the stuff that's in this chain, like this will, well, you don't really need that. This will become like a statement. This will become like a statement in terms of statements and reasons for our proofs. If you have this, again, this would come from your picture. You don't need to say like 1 and 2 are a linear pair. If there's a picture there, it's kind of a known fact. You don't have to restate it. But if you see linear pair in your picture ever, the majority of the time is you're going to say, I can look at this, those are a linear pair. That's what you think in your head. Therefore, the two angles are going to be supplementary. So you would write a statement saying angle 1 and angle 2 are supplementary. Okay? Like, so this would become like a statement somewhere. And if you're writing, it would probably be like a step 2 or something like that, because the first one is usually a given portion. Like they would have in words given. Your reasoning behind this, if you go in this route, and you need to use this, I have it listed as a cheat sheet at the top, meaning that every time you're working on proofs, like for classwork or homework, you need to go back to this for reference. Reasoning behind this is linear pair postulate. Okay? So if you, in your picture, see linear pairs, majority of the time you're going to say those angles are supplementary. Linear pair postulate would be your reasoning. And then most of the time, you could link that together by going, now I know those two angles add up to 1/8. Okay, which would be your next logical step. And reasoning behind that is definition of supplementary angles. So this is like a very common chain. Again, this would all stem from you guys having a diagram that kind of resembled that, or at some point in a picture you see a linear pair happening. So all the things that I have in that top portion, guys, are just very common things that pop up. Again, based on either something given to you or based on a diagram the way it looks. Okay? So what you should have is add these at the bottom. These are all reasons, right? Proofs are formed with statements and reasons. So the things with the arrows will be your statements. The thing below it, which you should have written in there, are going to be your reasons. Because guys, if you're in class working on a proof and you ask for help and you cannot produce me this paper and produce me all the stuff that's up there, I'm going to say find it, copy it from someone that I can help you. I can show you how to use that paper. Okay? Because most of the stuff you work with will be on. All right, so that's the first one. I'm not going to have the 1B, I don't think, up here. Yeah. I think I have 1B on your paper, correct? It's like this, but in the reverse order.
Yeah.
Yeah?
Yeah.
So if you do it in the reverse order where it's like 1 plus 2 equals 180, and then you say the angles are supplementary, just so you can fill it in. Below that, again, this would be statements. The reasoning behind this would be definition of supplementary angles. And then I shouldn't have anything after that, do I? It should stop right there. Okay. But there's nothing else I can say based on that. Okay. The next thing. I only have that picture again. This isn't something that would be a given to you. I'm just showing you with this one that if you ever run into angles that are congruent, or this also would apply to segments being congruent, then you can flip-flop back and forth between congruency and equality within a proof. The only reason you would do this would be if you started with congruent angles. So like, if I was looking at this picture, I would say 1 and 3 were congruent because those are vertical angles are congruent. Then if I needed to somehow work with an equation, if you've got an equation somewhere in a problem, like if you're doing a fill in the blank, or it says prove that these things are equal, you can't really work with equations with a congruency symbol in it. Equations, to make it 100% correct, you can only work with them if you've got equals. So if you've got something listed as congruent, you have to add a step that switches it to equals. The reason for doing this, and I've got the arrow going back and forth, meaning the same reason applies. If you start here and go here, or vice versa. The reason is definition. You just put definition of congruency, and that's fine. This is you only need this if at some point you see it flipped, or if you need to work with an equation, something like that. Like if I had to take this angle and plug it into an equation, I couldn't do it as it is here. I would have to switch it to equals and then work with it. Okay? We'll run into examples with all this, as time goes by, guys. This is just, remember, this is just like intro stuff. It takes practice, it takes time. Okay? All right, next thing, the next one down, okay? All right, again, this would be either a given, starting point, something, okay? So it's not like, this is not necessarily going to be always a given. It just means at some point within a proof, you're running into perpendicular lines. So like something like that would be an example of it. Majority of the time, if you've got perpendicular lines, the reason they're giving you perpendicular lines is to make an angle a right angle. Most of the time. All right, these are never 100% of the time. The reason you're allowed to say that is because that's what that word is. That word perpendicular means it makes right angles. If a word ever tells you what a property is or produces a property, your reasoning will always be definition of whatever the word is. So in this case, it was perpendicular, so you put definition perpendicular lines. Okay? And then for what we're doing right now, like this will change a little bit for the next chapter, but for right now, if you've got a right angle, most of the time, the point of having a right angle is to make it 90 degrees. And these are separate statements. Don't think this automatically puts that in the same statement. Proofs are very long-winded. So if you've got a right angle, again, this term right here means that it's 90 degrees. So if you add a step saying this measure of angle, whatever is 90 degrees, just put definition of right angle. If a word tells you to do something, and that your reasoning in terms of filling out a proof is always going to be definition of whatever the word is. And then if it's in reverse order, again, this is like, this portion here is like either a given or a starting point or something like that. If they tell you an angle is 90 degrees, most of the time it's going to be because they want you to say it's a right angle. So this, like that, this is definition of a right angle. And then for where we're at right now, usually the point of having a right angle, so you can see you've got perpendicular lines. And that's that. Okay. Almost all the problems today are going to be revolving around those. There isn't going to be much else we can add to it outside of like the alternate interior stuff, the alternate exterior, the things that we did the day before. Okay? All right, now. The examples I do, guys, so you don't have to write them out or draw them out, are in here. Along with your work will be in here also. If you guys go to the very back, the last pages, you'll see the examples. I think it's the front side of that last page, like that front of last. They're all two-sided. So. Okay, so I'll go through this one. All right. Again, I think most of the stuff that's up here is either going to be straight from the things I just gave you, or it's going to go from what we did yesterday, which when we get to this point, that's going to be a reason that we would have had yesterday, because this statement's saying that two lines are parallel, so that's what we did yesterday. All right. Now look, this one down here, it's linked to the same thing. The reason this is linked to the same thing is because they give you two sets of perpendicular lines. So they're using each one separately. So if this one is definition of perpendicular lines, that one also has to be. They're linked to the same situation. Okay? All right, now the next part here I don't have written down. We mentioned it probably the end of last chapter. This angle and this one are both right angles. How many degrees are both right angles? 90? So that's 90, so is that, yeah? If they're both 90, are they equal? Yeah. Okay, so the reason that these can just be said are congruent is because you just say all right angles are congruent. There was a theorem that we had written down. It was at the end of chapter 2. It's called like right angle congruency theorem. Okay? All right, so look, where we're at right now is, I know there's boxes on the picture, but really where we're at down here would be having these marked congruent. The positioning, one and two are here. Out of those angle pairs that we've been working with, right? Alternate interior, corresponding alternate exterior, same side interior. Where they have these drawn in here, which pair do they fit? Are they alternate interior, alternate exterior, corresponding, or same side interior? Corresponding. So I've got corresponding angles that are congruent. So remember you say corresponding angle, but now since this thing is saying that the lines are parallel, this would be what we did yesterday. So you throw that word on there. Okay? Do not, the paper that this is on, like there's going to be extra work that's in that packet that you're doing for homework. Keep track of the ones that actually have proofs on it. At least starting wise, what to fill in over there. We're going with what's on the front of this page, okay? It's not 1, 2, or 3 that's on there. This is going to be number 4, which we talked about on Monday and also yesterday. Okay? So with this one here, There's two things given to you. They're telling you that two lines are parallel, and they're telling you two angles are congruent. So in terms of me filling in the blank, I would just go over to there, and anywhere I saw either one of these, I would add the word given to it. That's why they put that word there. Okay? It means you don't have to do any work to find it, but you just put it. All right. On that front side, right, where the cheat sheet thing, number 4 should say something like parallel lines and then have an arrow pointing to things. Correct? What this is saying, from now until we are done with this book, if you see lines that are parallel, try and find angles that are congruent based on either alternate interior or alternate exterior or corresponding or whatever. All right. Now, they're only giving us these two lines. Okay? And if I look at it here, just kind of linking together this problem, since it's a fill in the blank, they're telling us to look at angle 1 and angle 3, which means I don't care about this portion down here, just for filling in the blank. So I would go, okay, here's 1, here's 3. There's my two lines that are parallel. That's my transversal. Where they have 1 and 3 marked, are they alternate interior angles, corresponding, alternate exterior, or same side interior? Corresponding. So using that, that's what I'm going to put here because of the stuff we've already talked about in the past. So this is corresponding angles. I don't put the word converse after it because the converse only goes with, like if you're saying something down here. If the parallel line thing's not there, you can throw the congruency mark at the end of it. So this came from 4. If you see this here, you're going to say two angles are congruent. That's just how it goes. Okay? All right, next thing. For this one here, again, this is going back to end of last chapter. Where I'm sitting at in terms of this fill in the blank is I've got these two right here. Between this statement and this statement, is there something that's exactly the same? Just look at 2 and 3. Is there something that's the same in both of them? What? Angle 1, right? So the way this is logically going is it's saying 1 and 3 are equal, 1 and 2 are equal. 1 and 3 are equal, and 1 and 2 are equal, 2 and 3 have to be. There was a property we had where you had a linking like this, and you had an overlap, and I said if you just take the overlap away, you can create a new statement. Do you remember which property that was? Transitive. So this is transitive property congruency. Okay? And then for the last step here, for you guys right now, this is proving that lines are parallel. The list is on the front side. 7 ways to prove that lines are parallel. If you put anything other than what's on here in that blank, you're doing it wrong. Okay? If you're asked to show that two lines are parallel, you pick one of those things that's on there that's 7. Number 7 should be thrown out because this isn't on a coordinate plane. So your options are only going to be 1, 2, 3, 4, 5, or 6. All right? And again, you always got to look at the step right before it to kind of lead you into what they want you to fill in the blank. So since the step before it used this angle and this one, I need to somehow classify those angles as a pair. So again, meaning I'm going back to alternate interior, corresponding alternate exterior, or same side interior. 2 and 3, what would I classify those as out of those 4? Alternate exterior. Okay. So I would say, okay, they're alternate exterior angles. I've got something that says alternate exterior converse on there. This comes from the bottom of that page. Okay? I've just kind of linked together everything we've done the past few days. These are, the one before this and this one are fairly decent examples for you guys to like go back and utilize when you're doing your problems.